Hey guys, welcome. In example 0, we learned how to derive the equation of a plane. In fact, we did a lot more using visuals. We really figured out how and why the equation of a plane works the way that it does. And we got to fully understand what the equation of a plane is all about. And so I strongly encourage you to watch that video because it's the most important video, example 0. All right, but in this video and at least one more, I'm going to give you practice. And so show you how to write the equation of a plane in a couple of different situations. And so in this situation, in example 1, we're given 3 points on a plane and we're asked to write the equation of a plane. And these points should be familiar because we worked with them in example 0. In any case, this visual from example 0 is going to help in case you don't want to watch example 0. And so given 3 points, what you need are 2 vectors in the plane. And so there are a few ways that you can get 2 vectors in the plane. And here's one way, which is to make a vector going from A to B and then another one going from A to C. But you could have, instead of these 2 vectors, made 2 others, one going from B to A and then another going from B to C. And those other 2 vectors are just as good as these 2 vectors. You end up with the same equation. But yeah, first, given 3 points, make 2 vectors like this. And once you have your 2 vectors in your plane, you take the cross product between the 2 vectors to get the normal vector. So get 2 vectors in your plane from your 3 points. So these 2 vectors would be good enough. And then you do the cross product between these 2 vectors, and that gets you this n vector, the normal vector to your plane. And n is the direction vector. It's what tells us the direction of your plane in a weird way. And yes, like hopefully you understand why this n vector gives us the direction of the plane. But if you want to know more, I'm not going to tell you more in this video. Watch example 0. And so that's why I said in a weird way, n is telling us the direction of the plane, because that's a secret that you could learn about in example 0. Okay, anyway, the process is make 2 vectors out of your 3 points, take the cross product between the 2 vectors, and that gets you this n vector. And this n vector is crucial to the equation of the plane. Okay, after you do that, which is find the n vector, then you need to make another vector. And here's how you do this other vector. You take a random point named xyz on your plane, so you know that you automatically can make, right? Just like put a dot on your plane and call it xyz. And then you can connect that dot to either B or A or C or any other point on your plane whose coordinates you know, right? Now, you make a vector out of that random point xyz, and then the other endpoint being either A, B, or C, or any other point whose coordinates you know. And so then that would be like x minus the first coordinate of this other point that you know, and then y minus the second coordinate of this other point you know, and z minus the third coordinate of this other point that you know, will make a vector. And if this other point that you know is B, it'll be this purple vector from B going to XYZ, the arrow towards XYZ. If you use a point C, then it will be this vector here from C going to XYZ. And if you use A, it will be this vector. And I typically just use A, but yeah, you make one of these purple vectors. And since this n here, the n vector, is perpendicular to the plane, it's perpendicular to any vector in the plane. And so it will be perpendicular to any one of these purple vectors. And that's how you end up with the equation of a plane. So in our case, if we first discover what these 2 vectors AB and AC are, it turns out that they are this here, -5, 1, 3, and -4, -2, 2. And I called this first one U, that is vector AB is U, and then this second one, vector AC, is V. So next we're going to do U cross V to find N. And so when we do U cross V, I've just stated the result because the cross product has its own video, so watch that to learn how to do U cross V. But yeah, if you do it correctly, then you get this vector. Notice that N is supposed to be perpendicular both to U and to V, and you could do N dot U and check that it's 0, or do N dot V, or both, and check that in both cases N dot U and N dot V are 0. Yeah? And so I know I've found the correct n. But I'm going to get fancy because I know that it's not just n that's perpendicular to my plane, but any multiple of n is also perpendicular to my plane. And since I want to work with smaller numbers, instead of using n itself, I have cut all of the components of n in half, and therefore I've done scalar multiplication. I've multiplied n by a half, the scalar 1/2, and I've gotten this vector that I'm going to use as my n vector instead. And I'm allowed that. I'd still end up with the same equation as if I had used this n here. Yeah? Okay, cool. And so we know that what's supposed to happen is n dotted with any of these purple vectors is supposed to equal 0. And so if we use the point A and then the random point XYZ, then we make this vector from A to XYZ, and I've called it P. And we know that what has to be true is n dot P. So the purple vector here dotted with n has to be 0, since the purple vector is perpendicular to the n vector. And so I do n dot P is equal to 0, and I know how to do dot product. I multiply corresponding components and then add the results. When I do, I get this, and then of course I know how the distributive property works, so I do that in collect like terms and do a bit more cleaning up, and here it is, final answer. Yeah? All right, cool. I hope you enjoyed this, and at least one more example to come, so keep watching. Take care.